So when we're looking at the unit circle, again, remember we're looking for in quadrants 2 and in quadrant 3 when the x-coordinate is negative square root of 2 over 2. The x-coordinate is square root of 2 over 2 at 3 pi over 4 and at 4 pi over 5 pi over 4. Do we see that? That's all you're looking for. Is like, hey, if it's non-calculator, that means I'm using the unit circle. Now, based on what we know about the inverse of a cosine, out of these two quadrants, which one does it narrow down to for cosine? To quadrant 2. The inverse is going to be applicable in quadrants 1 and 2. So the answer that we would be looking for is 3 pi over 4. Does that make sense? So our answer is 3 pi over 4. Oh, okay, pen. My pen got... Sometimes my pen sticks, and then it starts writing. When I try to move it, it just starts going, yeah. That's what I feel like it's saying. All right, so let's try this again. So for sine, we're looking for arcsine, meaning that we're looking for when y equals negative square root 3 over 2. Okay? So we're looking for when y equals negative square root 3 over 2. Y is negative in what two quadrants? 3 and 4. Okay? Y is negative in 3 and 4. So we know our answer lies in 3 and 4. The inverse is only active in which quadrant? 4. So we're going to look in what quadrant? 4 to find when does the y value equal negative square root of 3 over 2. So let me go back to that unit circle. Let me go back. Open. You're being... Thank you. All right, so we know we're in quadrant 4. We're looking for that negative square root 3 over 2. And negative square root 3 over 2 is that 5 pi over... We all see? Agree? 5 pi over 3. That's where the y coordinate is negative square root 3 over 2. And that's all it wants you to be able to do. So the answer would be 5 pi over 3. Now, this is the tricky part here. Because our interval is in terms of a negative, it wants you to write this as a negative because it's in quadrant number 4. Our interval is from negative pi over 2 to positive pi over 2. And 5 pi over 3 goes outside of that threshold. So we have to write this in its equivalent negative form. Okay? Writing this in its equivalent negative form just simply means I'm subtracting 2 pi. Does that make sense? To write this in its equivalent negative form, we are just subtracting 2 pi. Okay, and that's because sine is from negative pi over 2 to positive pi over 2. And I'm clearly way bigger than positive pi over 2. So I need to find its equivalent negative form. In order to find its equivalent negative form, we're going to do a little quick chopstick in a bowl and call it a day. Does that make sense? So chopsticking it. So my first chopstick, 5 pi times 1 is 5 pi. My rice is a little minus here. 3 times 2 pi is 6 pi. And all over my bowl, 3 times 1 is 3. So my equivalent negative form would be negative pi over 3. So now I'm in that range of negative pi over 2 to positive pi over 2. For degree, it would be, instead of subtracting 2 pi, you'd be subtracting 360, right? If it was in degree. More than likely, they will be in radians. Yeah. All right, so next, tan inverse, arctan of square root of 3. So this time, it's looking for a ratio between y over x, a ratio of y over x that produces the square root of 3, okay? That's our keep, change, flip situation, right? Tangent is positive in quadrants 1 and in quadrant number 3. However, the inverse is only active in quadrant number 1. So our answer lies in quadrant number 1. Let's look at this. So in quadrant number 1, you have two options that are possible to make that. these are my two options, pi over 6 and pi over 3. You're taking your y and multiplying it by the reciprocal of your x, right? Keep, change, flip. That's what y divided by x means. So if I was to keep, change, flip between pi over 3 and pi over 6, which one would leave me with a square root of 3 in the numerator? The pi over 3. Does that make sense? This would end up being 2. The 2's would cancel, and I would just be left with square root of 3. So the answer would be pi over 3. Does anyone need me to write that out or work it out, or are we comfortable seeing it? We're good seeing it? Okay. So the answer would be pi over 3. So these are examples of possible non-calculator type questions that you may get, okay? Obviously, they would be multiple choice because this would be on the multiple choice section. It also could be in the FRQ1, not FRQ1, FRQ. Yes, it could be in your FRQ1 if they choose to use a tangent function or inverse trig function. But you need to be able to read the unit circle. No, 2, because non-calculator. All right, here's an example of a possible general base question. So here you have a circle, and on this circle, it has drawn in all the different right triangles that are created within the circle of your unit circle, and it's just a general view of it. It's nothing about actual radian values. It's just making sure that you have an understanding. So I want you to read through the question. After you read through the question, you're going to best select the answer. You're going to best select which quadrant, and your quadrants or points are located. Which point represents what they're asking you for. So it's wanting to know which point could be the inverse, cosine inverse, which point could be the sine inverse, which point could be cosine inverse of negative x, which point could be the tan inverse. So your points are P, Q, R, and S, and you're going to put next to them a P, a Q, or an R and S here. And you're not guaranteed to use all points or all locations. Do y'all need me to do one with you? Okay. It's like y'all see. Let's do the first one together. So the first one's asking which one of these could be a possible angle of cosine inverse giving a positive ratio. Okay. So cosine, we know that cosine is positive in quadrants number 1 and 4, correct? So cosine is positive in quadrant 1 and 4. The inverse only exists in which 2 quadrants? 1 and 2. So out of these, I only can choose the point that is in quadrant number 1. And what point is in quadrant number 1? P. So the answer here would be P. So this is just making sure that you understand where things are positive and negative and where the arctans exist. Arc trig values exist. Okay, did that help? All right. All right, so let's talk about how we did on B. So on B, we have sine inverse. So we have arc sine of negative y. So what quadrants would produce a negative y coordinate? 3 and 4 would produce a negative y quadrant. Out of those options, which one can have a arc sine in it? 4. So therefore it would be what point? Point S. You're geniuses. Okay. Cosine. Out of which quadrants could I have a negative cosine? 2 and 3. Out of 2 and 3, which one can have a arc cosine? 2. So I circled both. That was an overexcited circle there. 2. So which one would it be? Q. And then tan inverse. Out of which at what quadrants do you get a negative tan? You get 2 and 4. Out of 2 and 4, which one does arctan exist? 4, so it would be S. Properties understood? All right, perfect.